Inside this episode, constructing a building like an erector set, we'll tell you how and why. One organization dedicated to easing international strife, passing the science and technology torch on to the next generation. This year's crop of STEM, or Science, Technology, Engineering, and Mathematics interns, present their research topics to NPS leadership as their programs come to an end.
This has been a remarkable journey for me and for you, I hope. It's remarkable how far you all have come in such a short time here. I'm thinking back to my days in high school doing science fairs, and my goodness, it's like night and day, the comparison for what you are able to do.
NPS hosted 85 interns this summer across different disciplines, including computer security, space systems, renewable energy, humanitarian assistance and disaster response, and the modeling of virtual environments. We spoke to a few interns and their mentors to find out what to expect from this upcoming generation of leaders in the science and technologies.
There's two different forces, so there's a repulsive force and an attractive force. When you give the robot a destination, that's the attractive force. The repulsive force is every obstacle in the way, so I always had a really high GPA. I was always good at math and always good at science, but I did not know what I wanted to do after high school. I thought I was going to go to culinary school. It goes towards the attractive force, but it veers away from the repulsive force, and it creates a vector in between. I think people would be intimidated by robots because there's a lot of hardware that can be damaged and it's expensive.
It's the Amigo.
Look at it, admire it.
It's
yeah,
Amigo.
it's a robot. There's a lot of work that we put into the robots, and they don't kind of want to ruin it. For me, I was intimidated because I know you have to program a robot, and programming for me was intimidating. I learned MATLAB. I didn't know anything about MATLAB. I didn't even know anything about a GUI. I didn't know what a GUI was, so I learned all of that this summer in 5 weeks. MATLAB is a programming language that is mostly focused on intense math, and that's what it was originally designed for, but what we're using it for is to program robots. The P3DX robot is a bigger robot, so we can mount a camera onto it and send it out into the field for reconnaissance and collect data before we actually send out troops. So in a way, we're kind of saving lives. A little bit more about the potential field. Our mentor wrote that program.
Last year I got really involved with programming robots, and I realized how much fun it is. And I thought it's not fair for me to have all this fun, so I wanted to bring some other people in. So here's the potential field, or the part of the potential field program right here. If I recall, when I was a student going to college, how I would have loved to have had an opportunity like this to work in a lab, work with some engineers. Each sonar, right, all 16 sonars, each sonar is located at some point out within this coordinate system, and that's what these points are right here. I expected the students to work hard and to not be daunted by the challenge that I was going to present them with. And I feel that Jessica, as well as her two colleagues, exceeded that. They weren't daunted at all.
After taking physics, electricity, and magnetism, I knew definitely this is what I wanted to do, but I had no idea what field. I knew a little bit about robotics, but not too much. I wanted to learn a lot more. And with this internship, I got to work hands-on with the robots and decided, yeah, this is really what I want to do. And what we did was we first learned MATLAB, and then we programmed the Arduino as well as the Raspberry Pi in MATLAB.
I'm very proud of this graph. I spent all morning figuring out how to do it with help.
Last summer, I was able to work with Matthew and two other folks that were volunteering in the lab, and I realized how much I really enjoy that. They've got just great ideas and all this energy. We did a survey of the entire Nimitz crew. So 3,000 crew members. How often do people have physical injuries? How often have you had, for example, lower back pain or shoulder pain? We're looking at the prevalence and incidence of these kinds of injuries. And then we also asked them questions about their sleep habits, you know, how tired they are, and we're collecting all of this.
These are actographs. When Dr. Shattuck and the other researchers go and gather data, they give these actographs to hundreds of sailors aboard ships or any other base of study. These measure wrist vibrations, and by looking at that data, we can deduce when the subject was asleep or awake. We have computer programs which can calculate, for instance, how fatigued a subject was during the period of data gathering.
Working those kinds of hours, which the Navy does, it has long-term health consequences. You can look at all the organ systems. You can see both cardiovascular, gastrointestinal, all the organ systems suffer because of this. I mean, it is really a health concern.
I've really loved my experience working with Dr. Shattuck these last 2 summers. She is an absolutely wonderful mentor and has personally gotten me really invested in this topic. I think that sleep research is something that I will pursue during my last year at Berkeley and potentially after I leave undergrad. This is one of my tests for the caffeine study. I have to mark as many of these numbers as I can. Also, as part of the NREP-CAP internship program, we are carrying out our very own research study. We're specifically interested in the circadian dip. By how much does drinking a cup of coffee alter daily bodily processes like temperature, response times, and awareness? In the data gathering portion, I'm already learning some pretty interesting facts about the range of variability that humans undergo in temperature and awareness across a single day. That really surprised me. I'm also learning some more techniques about the inherent difficulties in running a study with human subjects, but I'm also learning the real satisfaction that comes from asking a question and going out and finding the answers for myself.
I've been interested in the fields of science and technology.
You want to come help set up the copper on here? Let's go ahead and shoot this.
It's what the Navy encourages you to take during the ROTC path.
We're going to shoot one of these guys. Go ahead and load up the steel cylinder, and we'll do a shot with no momentum trap on this.
I did 2 years with the CAP program. My first year, I worked mostly with simulations on the computer, and then this year I did a lot more experimental things.
Okay, you got that set on there, Ryan? I'm going to go ahead and charge the gun. 60 PSI.
Mostly what I was doing this year is I was working on a project of Dr. Hooper's that's funded by the Office of Naval Research, looking into cold spray. It's a method for creating deposits of metal by spraying metal powders at high velocities at solid metal substrates. Cold spray is used in aircraft repair.
Okay, Ryan, you want to shoot this? Sure. Give me 1 second, and then we'll do our regular countdown.
3, 2, 1.
So my general strategy for interns, even at the high school levels, I usually put them on graduate level projects. In many cases, they don't necessarily have the mathematical background for a number of projects, but they can usually come in and learn the equipment and at least figure out how to do a lot of the processes, either from me or from the graduate students. Even if some of it has to be a black box, there's still a lot of hands-on stuff they can do. But I generally do not have separate projects for the interns. I put them on the same research that our primary group does. Typically,
you're trying to build up a large deposit when you're doing cold spray, but I was looking specifically at the individual particles, how they deform after they've impacted and bonded to the substrate, and then I was able to look at that through optical microscope and the scanning electron microscope and take cross sections to view the deformation. And we compare it to simulation work, and that all went into the final O&R presentation. This one has a higher cohesive strength.
Yeah, I think it's very challenging for people, especially in high school or early in undergraduate, to actually get experience what a real research lab operates like. So kind of my general goal is it's good for people to experience this and make sure this is kind of like the life that might be suitable for them.
You gave me a really realistic perspective of the academic world, of the hard sciences in general. I really don't know what kind of branch of the Navy I want to go into. Dr. Hooper has been strongly encouraging me to go become an engineering deck officer.
So I guess my motivation is predominantly selfish. My hope is he would go into the EDO track. He would eventually come back here as a graduate student and work in my lab, and I could get an additional couple years of work out of him, yeah.
I chose Columbia because it's one of the best universities in the country. They have a robust humanities program, so I'll probably be looking to get something a more technical kind of degree, like computer science. But I didn't want to sacrifice a good education in philosophy or history and other subjects like that I really enjoy. From this internship, probably the most valuable thing that I got out of it, I would say, would be the clarity regarding future career paths for me. Coming in last year, I really didn't know what I wanted to do, and now I've got a lot more clarity regarding what each path would hold and what would be best for me. For an intern coming in, I would recommend it as a great way to figure out what it is that you want to do, what kind of field and methods would be best for you.
Our future leaders in science and technology. After a short break, how the Naval Postgraduate School assists other countries in their times of need.
The Center for Civil Military Relations, or the CCMR, was originally established in 1994 to assist newly emerging democracies in the post-Cold War era. Today, the CCMR has expanded its focus, building partner capacity and improving interagency and international coordination and cooperation by addressing civil military challenges.
We often bring together a whole variety of people that have actually never gotten together before, from across foreign governments, from across our own government, from across our own services.
Reaching out all over the globe, partnering with nations.
We're building partnerships, we're building informal networks and formal networks.
To start a dialogue and a discussion and a debate.
We learn as much from the students as they learn from us. We facilitate this discussion. They all bring their own particular perspective and their expertise and their experience to the process, but oftentimes they haven't really come together to look at a problem like, what would you do in the event of a refugee flow or a natural disaster or a weapon of mass destruction release and so on in your country.
The CCMR has been recently assisting Albania in its efforts as an emerging democracy.
Our goal was to provide them with insights on how new democracies, emerging democracies, can effectively build institutions in terms of democratic civilian control of the intelligence agencies as well as intelligence effectiveness.
Tirana, capital of Albania, celebrated its Independence Day. They fought the fascists and later the Nazis. And now they were marching in triumph as an army under their own flag.
This independence was brief, as Albania fell under the control of the Soviet Union. As the Cold War ended in the 1990s, Albania regained its freedom, but suffered political unrest and economic collapse. The hardship was made worse by the Kosovo War. In 2009, the country joined NATO. In 2012, they celebrated its centennial. In June 2014, made progress to join the European Union. Despite recent turnaround, the country still faces many challenges as an emerging democracy.
And I think after 4 days of participation, we accomplished that. We got them to start a dialogue and a discussion and a debate regarding their security challenges, their intelligence challenges, their institutional challenges, as well as mutual understanding between the two sides, the outsiders of intelligence and the insiders of intelligence.
In response to the Syrian refugee crisis, the CCMR has been gathering security officials from neighboring Middle Eastern countries.
We have a course called Reducing Refugee Radicalization, which will be convening government officials from the countries of Lebanon, Jordan, Turkey, and Bulgaria, the nations surrounding Syria that are grappling with the Syrian refugee crisis. And we'll be working with them to discuss ways that they, as host nations for these refugees, can reduce the potential of the refugee populations from becoming radicalized and joining Al-Qaeda or other terrorist groups in the region. Education plays a critical role in providing another opportunity for people, especially children, so that as they grow up, they don't become radicalized, they don't join terrorist groups.
85% of the world's population lives near water. 95% of its commercial shipping is transited by sea. And in recent years, piracy and violence has been on the rise. Again, the CCMR has been coordinating with officials and practitioners in responding to maritime violence.
We bring in Navy and Coast Guard and civilian officials who have responsibilities for maritime security in their various countries. They come from around the world. The last iteration in April, we had 20 individuals from a number of countries. Some of the countries, example, are Mexico. We had a couple lieutenant commanders from there. We also had a Guatemalan naval officer. We had Sri Lankan naval officers, an Indian naval officer. And what we do is we help them work through some of the problems of interagency cooperation or multinational cooperation. And while they're here at the Naval Postgraduate School, they develop their own networks. And this is extremely valuable for the United States Navy, so we now have stronger partnerships with these naval officers from around the world.
Basically, any day of the year, you could beam down to almost any country around the planet and there's some sort of CCMR operation taking place.
For instance, we're involved in what's called the Gulf of Thailand Initiative, where we have representatives from Cambodia, Vietnam, Thailand, and Malaysia, and we try to work on how to prevent infiltration of weapons of mass destruction and components. And it's been very, very productive. They've actually signed MOUs, and it's proceeding very, very nicely.
In our final story, what it takes to construct a building like an erector set. From the Philippines, Brian Steckler tells us how and why.
My name is Brian Steckler. I'm the director of the Hastily Formed Network Center at the Naval Postgraduate School in Monterey, California.
I am the program manager of the evaluation of an advanced 3D printing machine that creates building framing materials from cold formed steel.
Cold formed steel is very easily shippable. It's very compact. It's a roll about 5 feet in diameter and about 2 feet thick and about 6 to 18 inches wide. So one roll can print out a building of about 16 foot by 32 foot in a matter of a half a day. Wood is hard to get in many countries. For example, the earthquake in Haiti, there was great difficulty just getting wood in the country.
The Navy Construction Battalion 1, currently deployed to Okinawa, Japan, has been assigned the task of testing the capabilities of this cold formed steel machine, since they will be the type of team to use the cold formed steel system when it becomes operational and in the field.
This is cold formed steel machine. In the back here we have the decoiler, where the steel is in a roll and it is decoiled back towards the machine. The machine tells it anytime that it needs a lip cut, any kind of dimples for screws, exactly where holes need to be. While the steel is still flat, it goes through here. You can have a cut for your service holes. You can have cuts for your electrical. You can have cuts so the steel goes together easier for screwing. After you get your service holes cut, the flat piece of steel continues through and it starts going through rollers. Now each one of these rollers bends it a little more. So as it goes through and it bends it a little more at a time, the sides come up until it's in a complete C. Once it gets into the complete C, it continues through and there's a lip put on the top edge in this area. After that, it goes through and a label is printed on. The label is basically just telling it, you know, what it's for. Is it a wall? Is it a truss? And what piece of the wall it is. And then at the last station, it cuts off your desired length. Over here, we start putting the pieces together to form whatever it is, a wall or a truss, whatever it is that we need. Put it together.
Yeah, that's short. This stud. Put it in.
So after we put it together, stand the walls up, screw the walls together with self-tapping screws, using anchor bolts to anchor it down to the existing concrete. After the walls are complete, we move to the roof where we swing our trusses up, use L brackets to anchor them down so wind doesn't come by and blow them off. And then you have your roof panels that go on last. After that, you sheet the roof and sheet the walls.
A building made out of cold formed steel with the amount of screws and fasteners that we put on the building can withstand close to 200-mile-an-hour winds. It'd be very difficult to build a wood-structured building that could withstand 200-mile-an-hour winds. You can do it, but you're going to be putting more and more wood in and more fasteners in to get that strength. The main sponsor of this project is the Navy Expeditionary Combat Command. NECC hired Naval Postgraduate School, me and the Hastily Formed Network Center to manage the evaluation of this product.
My name is David Maiano. I'm the Force Strategy Director for Navy Expeditionary Combat Command. Some time ago, the Marine Corps asked the Naval Construction Forces to look into the potential for light gauge steel construction. Private industry has been using light gauge steel construction for many years now. Therefore, we started to dive in deeper to this capability. We commissioned an operational assessment for the cold formed steel mobile factory. The NMCB-1 out of Gulfport, Mississippi is the air det that is performing this task. Preliminary data indicates that there is a potential for a decrease of 2/3 the amount of time required to be on station, and also a decrease of half the forces required from after-action reports that have been reported in past years. NECC commissioned the Naval Postgraduate School to conduct a business case analysis and return on investment. We also commissioned the Systems Engineering Division of NAVFAC Expeditionary Warfare Center in Port Hueneme to perform the operational assessment. So far it has gone very well. Obviously the assessment is not complete. We are still in preliminary stages, but the results that we are finding lends itself a tremendous capability in bringing the naval construction forces into the 21st century.
This morning when we put our first wall up, that wall took every bit of 30 minutes. Normally that wall would have took about 4 hours to form up with lumber. So being out in the field, we can set these at every spot that we have a battalion located. They can pump out steel for any building that needs to be put up anywhere within that location. So we don't have to carry this machine everywhere we go. We can put it in one spot and just pump out buildings, pump out dimensions, whatever you need. Before, for us in the Seabees, everything was lumber. So the time that it would take us normally to do a job is cut well in half now. The other problem we was having with lumber was we would use the local population lumber that they would have, and 3/4 of it would be no good. With this cold form steels, everything right on site. We no matter what size the building is, if we need to improvise, change something, it's all right there at our fingertips. We do a lot of jobs that people want, and we've been using what we call Flintstone technology to do Jetson's work.
We've got a couple students from the NPS Business School conducting a cost-benefit analysis and a business case analysis of the use of the FrameCAD system. So they're observing how it's being used in the field by the Seabees and working in conjunction with Navy Expeditionary Warfare Center to evaluate the metrics, to record and evaluate the metrics of the use of this system.
What we traditionally do with a business case or cost-benefit analysis is look at the monetized effects of a system and compare those against the status quo. And like I said, the status quo being wood frame or concrete block construction. We're going to collect data on site for a little while longer, but the biggest thing to keep in the back of our minds is to provide decision makers with objective and dispassionate analysis, especially in this time of fiscal austerity. Being able to take that academic side and marry it up with the actual operational side of the house is a great way for me as a student to come away with how everything meshes together, so that when I go on to my follow-on assignment at Headquarters Marine Corps Programs and Resources, I then have a baseline for how to conduct my job.
How long it takes to build a building, how much material it takes to build a building, how many fasteners, how many screws, how many people, how many minutes it takes to build a building, how the machine works in intense heat and humidity. We're measuring a variety of different factors. So the whole purpose here is to show the art of the possible.
In only 3 days, the Seabees were trained and able to reconstruct and retrofit buildings. Now they're able to construct an entire 16-foot by 16-foot building in just a few hours. This cold form steel system will have a very large impact on the ability of the Navy to rapidly provide humanitarian assistance with these new age construction systems.